Hey guys, today we are going to talk about 4 different proportionality theorems. The first one is the triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Okay, so here is a side of a triangle, and here's a side parallel to it that intersects the other two sides. Okay, so because those two line segments are parallel, it is true that RT is to TQ as RU is to US. Okay, so in this diagram, I've got QS and UT as parallel segments. So it is true that RQ is to QU as RS is to ST. So I'm looking for the length of QU. So 10 is to QU as 12 is to 6. Okay, so I can do some cross products here. I've got 12 times segment QU equals 60. And 60 divided by 12 is 5. So the length of segment QU is 5. Okay, so find the length of KL. So I've got my parallel sides here. So KL is to 18. As 44 is to 24. Okay, so my cross products are 24 times the length of segment KL, and 18 times 44, that's 792, and then divide by 24, KL is 33. So the length of segment KL is 33. Our second proportionality theorem is the converse of the triangle proportionality theorem. Converse, remember, just means you take the if and then part of a statement and turn them around. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. So here is a line dividing two sides, and it's stated here that it's done proportionally. RT is to TQ as RU is to US. And if that is true, then segment QS is parallel to segment TU. So this picture is a spoiler from a remote control car. It says CARE, that's not right, a remote control car. And on this spoiler, segment AB has a length of 31 millimeters. Segment BC has a length of 19 millimeters. CD is 27 millimeters. And DE is 23 millimeters. So the question is segment BD parallel to segment AE? So let's write a proportion. 27 is to 23 as 19 is to 31. Okay, so there's a couple different ways to determine if this proportion is true. One is we can simplify them. In fact, I don't think either of these will simplify. If they can simplify to the same ratio, then we know that this proportion is true, so these two sides are indeed parallel. Another way to find out is to check the cross products, because the cross products property teaches us that in a true proportion, the cross products are equal. So let's check the cross products here. So we've got 27 times 31 and 23 times 19. Okay, so that's 837 and 437. Those are not the same, so this is not a true proportion. So I would say that segment BD and segment AE are not parallel to each other. So is segment QT parallel to segment RS? Okay, so we've got 18 is to 38 as 36 is to 80. Okay, so we want to know if that is a true proportion. So let's check our cross products. We've got 18 times 80 and 38 times 36. If those truly are equal, then the proportion is true and the segments will be parallel. So 18 times 80 is 1440. And then 38 times 36 is 1368. That is not true, so that proportion is not true, which means that these segments are not parallel. So segment QT is not parallel to segment RS. So our next proportionality theorem is parallel lines and transversal proportionality theorem. So if three lines intersect two transversals, three parallel lines. So here are three parallel lines, and they are intersecting two transversals. So this is a transversal and this is a transversal. Then they divide the transversals proportionally. Okay, so that means that UW is to WY as VX is to XZ. So here is a farmer's land. So here's the north border, the south border, and a west border and an east border. So it is a trapezoidal piece of land here, and it is going to be divided by a new interstate. Okay, so the distances shown here are in meters. How long is the west border? Okay, so the distance between the north border and the south border, this west border, how long is that? So in order to find out, we need to know this length right here. So we have three parallel lines intersected by two transversals, so these are proportional. So 2000 is to X as 2500 is to 3000. Okay, so we'll do our cross products and we get 2500X equals 2000 times 3000. Okay, so that is 6 million. And we will divide that by 2500. And we get 2400. So we divide by 2500. And we get X is 2400. So 2400 meters right here. So how long is this distance CA, this west border between the north border and the south border? So we're going to add these two lengths together. So CA is 2000 plus 2400, which is 4,400 meters. Okay, so find the length of segment AB. So I've got three parallel lines and two transversals. So these are proportional. AB is to 27 as 32 is to 24. So I have 24 times the length of segment AB equals 27 times 32. And that is 864. And divide by 24. So the length of AB is 36. And our last proportionality theorem is the triangle angle bisector theorem. If a ray bisects an angle of a triangle, and that's what's happening right here, I've got a triangle, and here's a ray that bisects one of the angles. And I know it's bisecting because these arcs tell me that each side is the same size. So this is an angle bisector. So I have a ray bisecting an angle of a triangle. Then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So that means AD is to DB as AC is to BC. So here we need to find the length of segment DG. Okay, so here is my ray. It's actually drawn as a segment because there's no arrow, but either way, it's bisecting an angle of the triangle. So these two segments are proportional to these two segments. So X is to this other segment right here. So X is to this. Now I don't know this length. What I know is that all the way across here is 14. If X of that is right here, then over here is 14 minus X. So X is to 14 minus X as 8 is to 12. Okay, so my cross products are 12X. And here I'm going to have to distribute. So I have 8 times X, 8 times negative X, so that's negative 8X, and 8 times 14. 8 times 14, and that is 112. Okay, so I've got 8 times negative X and 8 times 14. Okay, so I can add this 8X, and I get 20X equals 112. And then I can divide by 20. So 112 divided by 20, and I get 5.6. So X is 5.6. What I'm looking for is the length of segment DG. Segment DG is X. So segment DG is 5.6. And last, find the length of segment AB. So AB is right here. I've got a segment here that bisects an angle. So that means these two segments are proportional to these two segments. So 1 is to 1 as the length of AB is to the square root of 2. Okay, so my cross products are 1 times the length of AB, which is just the length of AB, and 1 times the square root of 2, which is the square root of 2.